Hello, this is Gregory Maxwell, and this video lesson will be talking about summarizing data in a frequency distribution and using that frequency distribution to draw a histogram, frequency polygon, and cumulative frequency distribution, and and a cumulative frequency distribution graph, also known as an Ogive, O-G-I-V-E. The PowerPoint I will be using will be from the uh, Pearson Publisher, Elementary Statistics, using the 13th edition. I won't be using all the slides, but most of the slides, or all, most if not all of the slides that I use from the PowerPoint will come from the textbook publisher, and the information is displayed on the screen. Let's get started. So this is based on chapter 2 of the textbook, the Elementary Statistics 13th edition by Mario Triola. We're going to talk about frequency distributions and histograms, and we will also do a little bit on frequency polygon and the Ogive. Now, the key concept for this section is that we can organize large sets of data and even medium-sized sets of data into a smaller, more easily readable format. And the format we will start out with will be a frequency distribution, also known as a frequency table. The frequency distribution is basically a table with two main columns. The first column is a set of categories called classes, and the second column is the number of items in each category called the frequency. We will then continue from there and build additional columns to give more details for greater analysis in later concepts, in the later applications of the concept. But for now, we'll start out with the basic. So the frequency distribution, also known as the frequency table, shows how data are partitioned among several categories called classes, and the listing of the categories along with the number of items in each category, which is the frequency. Now, partitioned, the word partitioned here means that all the data is put into at least one class, exactly one class, I should say. That means each data value must go into one class, and no data value can go into more than one class. And so every data value should be used up, and no data value should be in more than one class. Now, there are some terms that we need to know for the frequency distribution. These are the definitions. We have class limits. We have lower class limits, upper class limits, and then we also have things called boundaries and class midpoints, also called the class marks and the class width. So let's talk about those. The lower class limits are the lowest values allowed in a particular class. So, and the upper limits are the highest values allowed in a particular class. And then the class boundaries is the halfway mark between the upper limit of one class and the lower limit of the next class. All right, so pardon me, let me just do a little setup here. So the lower limit would be if we have, for example, a lower class, if we have, for example, if the lower limit of a class is 50, then the lowest number allowed in the class is 50. The class then 49 or lower cannot be in the class. Then class and the class will not include 49. And I apologize for my writing here. Usually I would have a better handwriting. For some reason, my handwriting is horrible at this time. Now, if the upper limit is a similar measure, but this time it's the highest value allowed in the class. So let me just use an example here. So for example, if we have a class that is 50 to 59, then the lowest number allowed in the class is 50, and the highest number allowed in the class is 59. No value lower than 50 will be allowed in the class, and no value higher than 59 will be allowed in the class. These are all, if you had a number like 52 or 57 or 58.3, those would be allowed in this class. But if you have a value like 40 or 49 or 49.7 or 59.3 or 60, those would not be allowed in the class, because the lowest value allowed in the class is 50 and the highest value allowed in the class is 59. So 50 is the lower class limit, and 59 is the upper class limit. Now we'll do an example with this so you'll see more of what I'm referring to. Now, additionally, we have what we call a class boundary. So the class boundary is kind of like the fence between two classes. So I'm going to give an example real quickly here. I'm just going to randomly make up two classes. I have a class that goes from 40 to 49. That's one class. And then I have another class that goes from 50 to 59. The class boundary between this class and this class, the 40 to 49 class and the 50 to 59 class, is a number that's halfway between the upper limit of this first class and the lower limit of this next class. If I could imagine them on a spectrum, we could have one class going from 40 to 49 and the other class going from 50 to 59, and then halfway between them would be the 49.5 mark. That is called your class boundary. Imagine that each class is a property, and the fence between the property is the boundary. Okay? Now please note that the class boundary is not a value in the data set. The class boundary cannot be a value in the data set because it's supposed to be between two consecutive numbers that could possibly be in the data set. If the class boundary could be in the data set, then we are not setting up our classes correctly. So the class boundary is not a value in the data set. It's halfway between two possible values in the data set. The next type of value we're going to talk about here are the class midpoints. And the class midpoints are very important. They are the class midpoint is a value that would represent all the value in a class if we don't know all what values are specifically in the class. And the class midpoint is just the value in the middle of the class. And it's very simple to find it. You just average the lower limit and the upper limit of a particular class. So the lower limit, if we have a class the class is 50 to 59, then the class midpoint, also called the class mark, the class midpoint or the class mark, is simply the halfway value from 50 to 59, which we obtain by just adding 50 plus 59 and then dividing that by 2, and that will give us 54.5. So that's the class midpoint for that class. Then we will do that for each class. Now, the class width is now very simple. The class width would simply be the value, the distance between two consecutive values of the same type. So the class width would be the distance or the difference, between two consecutive lower limits, and I'll just add or two consecutive upper class limits or two consecutive class boundaries. And let me just wind this a bit. Or two consecutive class midpoints. In other words, if you take any two values of the same type and you find the difference between two consecutive values of that type, then you have yourself your class width. And when we construct a frequency distribution, the class width must be the same for each class. Okay, so let me back up here a bit and take a look at this example that I just wrote up here. If you notice here with this example, we have one class is 40 to 49 and one class is 50 to 59. The class width is, what I do is I got the two lower limits, 50 and 40. I do 50 minus 40, that's 10, so the class width would be 10. Or I could look at the upper limits. 59 minus 49 is 10. And if I use a class mark for this and the class mark for this, that difference between those two class midpoints would also be 10. So that is the difference between, that is what a class midpoint, a class width is. A class width is the difference between two consecutive measures of the same type. Either two lower limits, two upper limits, or two class boundaries, or two class midpoints. Consecutive midpoints, consecutive boundaries, consecutive lower limits, consecutive upper limits. That's the difference between those. Please note that there's a common error that's made where people, in trying to find a class width, they do upper limit minus lower limit. That is an error. You should not do that. That is not how you find the class width. You can find the class width by doing the difference between two consecutive lower limits, or the difference between two consecutive upper limits, or the difference between two consecutive boundaries, or the difference between two consecutive midpoints. That is how you find the class width. Now, right here gives you an idea as to how to construct a frequency distribution from values. Now, what you want to do is decide on the number of classes unless you're told how many classes to select. And then what you want to do, you want to use classes between, say, 5 and 20 classes. More than 20 is a lot. Less than 5 becomes, well, it's not absolutely necessary. It doesn't give you as much data, as much description of the information as you'd like, although you may see people do that. Then you need to decide what the class width is going to be. Now, to do the class width, generally speaking, what people do is they find out the range of values. In other words, what's the highest value minus the lowest value, maximum data value minus minimum data value. And then you divide that by the number of classes you want to have. So let's say you wanted to have 10 classes, and the highest value is 200, and the lowest value is 95. Then you would do 200 minus 95, and that would be 105. Then you divide that by 10, and that would be 10 point some number. And then you just round up to the nearest whole number. So your class width, it would be 11 or something bigger than 11, say 15. It doesn't have to be exactly that number. You can round to a convenient number. So if you do this operation here and you get something like 10.5, you want to use a class width of 11. But if that's too inconvenient, you might want to use a class width of 12 or 15. Just know that that may affect your number of classes. Okay. Now, once you determine the number of classes, you need to choose a lower value for your first lower limit. That lower value must be either the lowest value in your data set or a number lower than that. You cannot choose a lower limit that is not at least the lowest value in the data set, because then you will leave out some values out of your frequency distribution, and that is not allowed. Then, once you determine your lower class limit, what you will then do is use your class width, which you would have decided or would have been told to you, and you just figure out all of your lower limits from there by just adding the class width to get the next lower limit. So if your first lower limit is 15, and then your class width is, say, 10, you start out with 15, then you add 10, so your next lower limit would be 25, then you add 10 to that, your next lower limit would be 35, and then just keep adding 10 until you cover all the lower limits. Once you have all your lower limits, then you would use the next value before that to the in the data set, to the number of decimal places in the data set, to represent your upper limit. So let's say here that your lower limit for your value, your lower limit for your classes was um, 15, but the values are written in decimals like 15.3, 15.7, 15.9, 16.8, etc. And let's say your lower limit is 15, then and your class width is say 5, then your next lower limit would be 20. And let me just write that down just to give you a little illustration here. I'm going to do a more detailed example afterwards, but what I'm trying to illustrate is that if you have a class width of say 5, and let's say your values are numbers represent to one decimal place: 15.3, 15.7, 15.8, 16.2, 16.5, 16.6, 16.9, 17.0, 18.1, etc. And let's say my class width is say 2, and my lower value is 15 for my first class. If my first class is 15, my class width is 2, I'd add 2 to that, and I'll get 17. Then I'll add 2 to that, and then I'll get 19, etc. Now the problem is my answers are not going by whole numbers, they're going by decimals. So since the decimal is to one decimal place, my values must jump by 0.1. So I'm going to change my lower limit from 15 to 15.0 because I want to make sure I know that I cover my decimal places. If all my numbers were whole numbers, then I wouldn't do 15.0. I would just do 15. But since they're whole numbers, my lower limit would be 15.0. My next lower limit would be 17.0 because my class width is 2. My next lower limit would be 19.0. Now, the number to one decimal place that comes before 17.0 would be 16.9 because my answers are in one to one decimal place. So I can't say my previous number is 16. It has to be 16.9 because all my numbers are to one decimal place. And then to get my next upper limit, I just add 2 to that, and that will be 18.9. And then my next limit would be 20.9, etc. And then I can proceed with my value from my distribution from there. So that's what I mean by when you're determining your class limits. You have to make sure you pay attention to the precision of your data. If your data is whole numbers, then your values could be whole numbers. But if they're decimals, then your values should be decimals to that number of decimal places. And you must make sure that there could be no number that goes between the upper limit of one class and the lower limit of the next class. There should be nothing that can fit in between them from your data set. Then you want to count out how many values go into each class, and you fill that information in. And once you fill that information in, you can then you can now create your frequency distribution. Some people create a tally chart and then they count the frequencies. In this case, we're not doing that. This is an example we're going to do a simple chart from. So using this is McDonald's lunch service times. Using McDonald's lunch service times in the first table, follow the procedure shown on the next slide to construct the frequency distribution shown in the second table. Use 5 classes. So we want to use 5 classes. So this is the answer we're going to receive. This is what we're going to get. We have 1, 2, 3, 4, 5 classes. Question is, how do we get all of these answers here? These are the values we have. Let's see how many values we have. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have 50 values because 3 times 17 is 51, but we didn't use this last cell, so it's 50. So we have 50 values in all. So what do? First, we decide how many classes we want. They say 5 classes. So what I do is I find out what my highest value is. My highest value in the data set was 308 seconds and the lowest value was 83 seconds. And you can see here the highest value is, let's see if we can find that highest value. I didn't want to go searching for it ahead of time, so I just looked at what was there. 308 was the highest number. There was no higher number there, and the lowest number was 83. There was no lower number there. That means the lowest wait time was 83 seconds, and the highest wait time was 308 seconds. We subtract them out, and that will give us, when you subtract 308 and you minus 83, that gave you 225. And then when you divide 225 by 5, that gave you 45, exactly 45. That means your lowest class limit, your lowest class width has to be 45. In reality, it may have to be bigger than 45, maybe 46. So we just round it to 50 and say, okay, we're going to make our class width 50 because 50 is a convenient number that is bigger than 45. No one says we have to use this exact number or any particular exact number. We just use a number that's a little bit bigger. So we're going to use a class width of 50. And then we're going to decide what our lower limit is. Since our lowest value is 83, we could start off with a lower limit of, say, 80. But in this case, we started off with a lower limit of 75. But you could have started off with 80. In this example, we chose to start off with 85. What we couldn't do is start off with a number that's higher than 83. The lowest number we could start off, the highest number we can use for lower class limit for the first class was 83. That means if you have a lower class limit, it must be 83 or a number that's less than 83. We chose 75. So our lower limit is 75. That means since our first class has a lower limit of 75 and our class width is 50, to get to our next lower limit, we just keep adding 50. So we add 75 plus 50 gives us 125. That's our next lower limit. Then we add 50 again. That gives us 175. That's our next lower limit. And we just keep adding 50, adding 50. Now, if you notice, all the times are whole numbers, no decimals. So that means our numbers are jumping by whole numbers. So since my lower limits are now indicated, 75, then 125, then 175, then 225, then 275, my upper limit would be the number that comes before 125. That would be 124. And then I just keep adding 50 to those to get my next values. 124 plus 50 will be 174, plus 50 will be 224, plus 50 will be 274, plus 50 will be 324. So I can then fill in that information. So if you notice, my upper limits are also separated by 5. All right, so let me just save this slide here. And I had already saved it. So I will continue from there. And then and I will just make reference to this afterwards. Now, the next thing, what we've now done is we have created when we did all of that stuff, our basic frequency distribution. The basic frequency distribution has 2 columns. One column indicating your classes, which in this case is time in seconds for waiting, and the other column is your frequency. That's your basic frequency distribution. Now from there we can add on more details. And we're going to do that right now. We're going to add on more details. Now, what am I going to add on here? I'm going to add on a couple of extra columns right now. And those extra columns are going to indicate some information I'll need to use later on. I'm going to add on a column to represent my class midpoints, and I'm going to add another column to represent my class boundaries. So I'm going to just extend my table here a bit. I'm going to kind of draw an additional box here. And I'm going to create a couple of additional columns. And my columns, one column will be my class boundaries, and the other column will be my class midpoint. So let me just try to work that situation out right now. So I'm going to go there and I'm going to take this and create my class. It's not going to be perfectly lined up, but this will be lined up enough for our purposes. All right, so what I'm going to do now is I am going to put in my class boundaries. Have to make it small enough so it can fit in the space. And then I'm going to do one for my class midpoints as well. All right, so mine here is a little bit big. So let me just make this a little smaller for the sake of fit. And then my class midpoints, also called the class mark. All right, so let's start off with our class midpoints. So our first class midpoint will be, and I'm going to bring up my little calculator here. My first class midpoint would be halfway between 75 and 124. So I'll do 124 plus 75, and then divide that by 2. That number is 99.5. So my first class midpoint would be 99.5. So let me just type that in. All right, then I can now calculate all my class midpoints very easily. All I have to do is just keep adding 50 to each of those numbers. So I can then just add 50, and that will give me 149.5. Then I just add another 50, and that will give me 199.5, etc. So what I'm going to do now is add those numbers in. So I'm going to do 149.5, and I'll just put those in, then 199.5, and then I'll put in 249.5 because I just keep adding 50. Then I'll put 299.5, and that will be my last. So I'm just typing them in here. Those are my class midpoints. Next, what are my class boundaries? The class boundaries are the values halfway between one class and the next class. And you can see halfway between 124 and 125 is 124.5. 124.5. So that we are going to type that in right now. 124.5. And then the next one would, of course, would be 174.5. The next one would be 224.5. And then the next would be 274.5. And as you can see, the class boundaries are all separated by 50. Now, one of the things you would also recognize that we have a space for a boundary before the first class and a boundary after the last class. Well, we don't have one for a boundary after the last class, but we can imagine there would be one. So I'm gonna imagine what would be the boundary if there was a class before this one, and that boundary, of course, would be 74.5, because again the class boundaries are separated by a distance of 50, because that is the class width. That is the class width. So what we've just done now is we've added 2 additional columns to our frequency distribution. And oh, sorry about that. And that would be our class boundaries and our class midpoints. And so that's how simple that is. Basic frequency distribution, class midpoints or class marks, which will be used later on for some important purposes, and then class boundaries. Now let's move on a little bit and talk a little bit about, oh, sorry about that. Let's talk a little bit about frequency, relative frequency. The relative frequency is what percent of the values fall within a class. It's what fraction of the total are covered by the frequency of that class. And it's very simple. Just divide how many items are in that class, the frequency of a class, by the total number of values you have in all. And then to turn that will give you a decimal, which we usually represent it to 3 decimal places or exactly. We prefer exact representation, but if it's not possible, you do 3 significant figures. And we also could write that as a percent by multiplying it by 100. So that's called a relative frequency. And then you can do a relative frequency distribution from that. So what I'm going to do now is I'm going to create a relative frequency column for the class that I just did, for the table I just did. So I'm going to just duplicate this slide. And now I'm going to do the relative frequency distribution for that slide. So how am I going to do that? Very simple, the same way I just did the other one. I'm going to add on another column, but this time I'm going to add it on the end right here. And then I just paste a few lines. Actually, I should have made this a little bit longer. Pardon me the delay in this. I'm just trying to get everything right here. And there we go. And then there we go. So I'm going to put my heading here, relative frequency. And let's see how that works. It's a little big, but it will work fine. And then we're gonna put in our relative frequency. How do I find my relative frequency? Well, the total number of values should be 50, which I could get by adding these frequencies. 11 plus 24 is 35 plus 10 is 45 plus 3 is 48 plus 2 is 50. So the relative frequency here is 11 over 50, and I'm going to write that as a percent. So I do 11 divided by 50, and that should be 0.22, and then I multiply that by 100, and that will give me my percent, 22%. So I can either write this as 0.22, or I could write it as 22%. Either of those would be acceptable. So that would be the answer for that one, either of those two values. All right, and so let's put in the others as well. So the next one would be 48% or 0.48, which could also be written as 48%, as I said. And then we could also do the 10 would be 20% or 0.2, and that could be written as, of course, 20%. And then 3 would be 0.06 or just 6%, and 2 would be 0.04 or just 4%. And of course, when you add up all of the decimals, that should add up to a total of 1. And if you add up all the percents, that should add up to be a total of 100%. And we can check that out right now. Let's just do the percents. So when you add 22 plus 48, that's 70, plus 20 is 90, plus 6, 96, plus 4, 100. And here you have your relative frequency distribution, your relative frequency. So we have a frequency distribution with added details about class midpoints and class boundaries, which will be useful for a later purpose. And then we added on information to that for the relative frequency. Now, just a reminder here that the relative frequency, again, the sum of the percentages should be 100%. Now, if you did a little rounding, it may be slightly off because of rounding errors, but you should also remember that the relative frequency should add up to be 100%. Now, there's one more type of chart that is based on that, and that's called a cumulative frequency distribution. A cumulative frequency distribution is a distribution that tells you the total so far. Cumulative means the sum up to this point, okay, or the total up to this point. Now the frequency distribution, the classes are how many items are in each in that category. But the cumulative frequency distribution is how many items up to a certain point. And so some people try to attach a cumulative frequency column to the frequency distribution, but I would prefer to create a new cumulative frequency distribution where the classes are the total are indicated by the numbers here, less than a certain amount. And then the cumulative frequency is how many numbers fall into that category. So here's how we work. The classes, instead of being how many the items that the lower limit to the upper limit, the classes tell us how many items come up to that point. And the way you do that is you either use the lower limits of a class or the class boundary. And what you do, you say, for this class here, you're asking how many items come before the lower limit of the next class. For this one here, you're asking how many items come before the lower limit of the next class. Or you could say how many items come before the boundary. So if we go on to here, the less than 125 means how many items are before the lower limit of this second class. That would be all the items in the first class, which would be 11 items. Then if I ask how many items come before 175, that would be all the items in the first and second class combined. That would be 35. how many items come before 225 would be all the items in the first, second, and third classes combined, etc. So the labeling for the classes for the cumulative frequency distribution is not the same as the labeling for the classes for the frequency distribution. The cumulative frequency distribution is designed to ask how many items up to a certain point, which is up to the lower limit, up to and before the lower limit of the next class. How many items come before the lower limit of the class after the first class? 11. How many items come in the first two classes combined? That means less than the lower limit of the third class, 35. And we do that. And if you notice here, how many items are less than 325? Well, the highest class went up to 324. Everything comes before 325. But 325 would have been the lower limit of another class if there was a class after the last class. And we're saying how many items are there before 325? All of them. So that would be the cumulative frequency distribution. And this would be the cumulative frequency distribution chart for that information. So that is how you set up a frequency distribution. What we will do next is talk about how we will create a frequency histogram to represent that information. And we will also do a chart for the cumulative frequency distribution called an Ogive. All right, so let's take a look at histograms. Histograms. Now, histograms are the next step from a frequency distribution. It's basically a bar graph based on a frequency distribution. And of course, you can draw a histogram from a frequency distribution or a relative frequency distribution. So, while a frequency distribution is a useful tool for summarizing the data and investigating the distribution of the data, an even better tool would be a histogram because it allows you to see the data in some type of graphical way and get some general information relatively quickly. So let's take a look at a histogram for the data that we just did. Histogram is a bar graph consisting of bars that are of equal width. The widths represent the width of the classes, and the height of the bars represents either the frequency or the relative frequency, depending on whether you're doing frequency distribution or relative frequency distribution. And let's take a look at the frequency distribution for the data that we just looked at, the wait times for McDonald's. There we go. Before I look at that, it's important. The histogram has some uses here. Helps you to figure out what the center of the data is, which is about either mean, median, or mode, which we'll look at later on. How spread out the data is, and if there are any outliers, it can give you an insight into whether there was going to be an outlier or not. Now, that said, let's take a quick look back at what we had from the McDonald's. This was our frequency table. This is the corresponding frequency distribution. Now, the only thing I would recommend when you're doing a frequency table is to allow an additional space here for at least the width of an additional class that is empty. So there would be the line would extend here. If you notice, we're not really concerned about being precise about the x-axis starting at 0, because that would be too long a line from the beginning. We just want to make sure that the class widths are the same. Also, the bars must be touching. So where they touch must be the class boundaries. So the first boundary would be 74.5. That would be the lower boundary of the first class. The boundary between the first and second class is 124.5, and the bars must be touching. The bars of the histogram must be touching. All right, and then you should label your chart. McDonald's lunch service times in seconds. The x-axis is seconds. The y-axis is the frequency. And then you could either label each boundary, or you could just use a column to indicate the label of the class, like 75 to 124. So those are the best two ways. I recommend that you use the boundaries because they give some nice detail. and you can always find a class midpoint by just finding halfway mark between two boundaries as well. And that is a relative frequency histogram. So the relative frequency histogram allows you to get some information. They use that little CV dot for a summary of some information that it tells you. It allows you to analyze the center of the data, which is mean, median, mode, variation of the data, such as range, and kind of like an idea of how spread out the data is. The shape of the distribution, such as uniform distribution or normal distribution, or whether it's skewed one way or another, and it also can help us to identify outliers if there are any. A quick idea of some frequency distributions are these. This is a normal distribution, which we'll study later in the course. A uniform distribution, which basically the heights are approximately the same. And then you have one that's skewed to the right, even though the bulk of the values are on the left side. It's saying that the mean is on the right. In other words, let's say we have a test and most people score low on the test, but somebody scored pretty high. It makes the mean value higher than what most of the values is. So the data is actually skewed to the right because the mean is to the right of most of the values. And then when it's skewed to the left, the mean is to the left of most of the values. And then the normal distribution, the mean is approximately in the middle where most of the values are. So that's an example of how the distributions could be represented. So as we see, you have a normal distribution or approximately normal distribution. That's a histogram that represents that. And there are some others that we could look at, like something that is skewed, that's either skewed to the right, as in this case, where it's positively skewed because the mean makes the data look bigger. The mean of the data is greater than most of them, or it's negatively skewed where the mean is less than most of the data. All right. So that is an example of how a histogram can help you. There's some other uses of histograms, but we're not going to go into that right now. What we're going to do is practice on drawing a frequency, a histogram from a frequency distribution. Before I talk about the graph of a frequency distribution, I need to talk a little bit about the frequency polygon. The frequency polygon is a polygon that is built off of the histogram of a frequency distribution. It's actually relatively easy to do. What you do with a frequency polygon is you take the histogram and seems I had neglected to get my histogram from my information here. So I will drop it in right about here, and then we will be able to talk about that. So let's look at the histogram, and then we'll look at the frequency polygon immediately afterwards. So the frequency polygon is a graph using straight line segments connecting the points directly above the class midpoints of values. A frequency polygon is very similar to a histogram, but a frequency polygon uses line segments instead of bars, and the line segments are not made at the end, at the boundaries, it's made over the midpoints. A variation of a basic frequency polygon is a relative frequency polygon, which is basically the same, except we're using relative frequencies, just like there's a relative frequency histogram. So if you recall here, we had a histogram. This is the relative frequency histogram, actually. Oh, sorry. No, this is the actual frequency histogram, not relative. So let's mark that one off here. This is not because this is 24, 11, 11, 24, 10. So this is the frequency histogram, not the relative frequency histogram. So in this case, we're looking at a frequency histogram. And, oh, pardon me, let me just fix this little situation here. We have a frequency histogram here. All right. And what we're going to do is use this frequency histogram, and we're going to create a frequency polygon. So this chart is bar is the frequency histogram. How do we create a frequency polygon? What we're going to do is take our histogram, and we're going to mark the midpoint of each bar, which would be where the class mark is. So the class mark for this guy here, and then the midpoint of this bar would be over the class mark or class midpoint for that class, etc. So we would start marking the midpoints. Now, the one important thing you need to also remember, you need to imagine that there's a class that goes beyond the last class and a class that comes before the first class. Based on how this chart is represented now, it's not easy to see. So what I'm going to have to do is I'm going to have to do a little adjustment here, just for the sake of the what we're doing here. So I'm going to do a little capture, and I'm going to kind of try to mess around with this a little bit. It's not going to be a really good situation, but we have to work with what we have. All right, and then I'm going to create a little problem here. I'm going to move my chart over to this side. And I'm going to do a little adjustment here. So if you notice, what I've done is move the chart over a little further. And you may be asking, why am I doing all of this work? And I'm going to explain why. The reason is so that I can create an additional class at both ends of the chart. I'm going to create an additional class at the left end, before the first class, and an additional class before the last class. So imagine that I added 50 to this, and that would bring me over to 374.5. The mid of that class would be empty, and I'll just put the midpoint there. And if I subtract 50 from this, that would bring me down to 24.5, say right about here. And that class would also be empty. And I'm going to try to do the middle of that class. And what I've just done is created two new classes that have nothing in them. I created a class before the first class and a class after the last class, both of which would be empty. And the reason I do that is when I'm now drawing my frequency polygon, it must start on the x-axis and it must end on the x-axis. So I need a class before the first class that is empty, and a class after the last class, and those classes must be empty. And then I will join the consecutive midpoints at the top of the bars. So from the x-axis up to the top here, and then another one right there. Then I'm going to that next one here, and I'm using straight line segments to join those segments, those points. That's one I didn't do too well, so I'm going to redo that one. Oh, messed up again. And then my last segment should end on the x-axis like that. This blue graph here is the frequency polygon. That is my frequency polygon for the data that I just did right there. And now let's take a look at what it should look like without the histogram over it. There we have it. Somewhat similar to what I drew. If you notice here, I think they did something a little bit. Oh yeah, sorry. If you notice, these are all the midpoints of the bound of the classes. This midpoint would be for the class that I created before the first class. The midpoint would be 49.5. You notice that's a class before this one. And the last midpoint was the midpoint I created after the last class. If you notice, that's outside of the range of these guys. And let's see, it's at 349.5. And if you look at the shape of my blue graph here, it's basically the shape of their frequency polygon. And that's a frequency polygon. And I guess you can intimate from this information that you can backtrack from the frequency polygon back to the histogram and get some, and even rebuild the frequency distribution table from either the frequency polygon or the histogram. Now, what we're going to do is we're going to do an example to illustrate our point. And for some reason I included that one, but let's go to this one here. So I'm going to do two examples here. Hopefully they won't take too much time to do, but they are good for an illustration. I would recommend that you try these questions before I do them, and then you follow up by checking the answer by looking at the video to see if your answers are the same as mine. And if they're not the same, you might want to figure out what you missed, or if you think I made an error, you can probably contact me and then I will adjust. So this question is from the OpenStax textbook, Introductory Statistics, which you can find at the openstax.org website or on the OpenStax app. It's on Chapter 1 Practice. This is from question number 84. It says Forbes magazine published data on the best small firms in 2012. These were firms which had been publicly traded for at least a year, have a stock price of at least $5 per share, and have reported annual revenue between $5 million and $1 billion. The table below shows the ages of chief executive officers for the first 60 ranked firms. All right, so these are the ages, and these are the number of people in that age range. And they say they left the frequency area blank. We're going to look at that in a minute, and then we're going to answer these questions, okay? So the first thing we will do is just do our frequency distribution here. And they told us it's 60 people in all. We can check quickly. 3 plus 11 is 14, plus 13 is 27, plus 16, 27 plus 16 is 43, plus 10, 53, plus 6, 59, plus 1 is 60. And then we can find our relative frequency by just dividing 3 divided by 60 is 0.05. So I'll just type that in, I'll just write that in right now, 0.05, or we can say 5%. And then we can do 11 divided by 60, and that one is 0.18333. The 3 is repeated, and so that's 18.3%. And then 13 divided by 60 is 0.216 repeated, which is 21.666, etc. percent. I'm just going to write the bar over, but it should be 21.7 if you round to 3 significant figures. And then 16 divided by 60 is 26.6 repeating percent, or 0.26666, which is 26.6 or 26.7 if you do 3 significant figures, 26.7%. I'm going to write it as a repeated decimal to keep the trend going. And then the next one is 10 divided by 60, which is 0.16666, which is 16.6 repeated percent, or 16.73 significant figures as a percent. And then 6 divided by 60, of course, is 10%. And of course, you could either use the percent or use the decimal. Either one will be fine. And then, of course, 1 divided by 60 is 0.01666. Three significant figures. So that would be 1.67%. All right, so that's the relative frequency. Now the question is, what is the class width? Very simple. You just look at the two lower limits and subtract two consecutive lower limits. 45 minus 40 is equal to 5. So the class width is 5. You could do 49 minus 44, 69 minus 64, 65 minus 60. They will all give you 5. Those are your class widths. The next question is, indicate the class boundaries and class midpoints for each class. And what I've done is I've taken the liberty of creating a piece of the chart here. And what I'm going to do now is find all my class boundaries. Relatively simple. As you can see here, the boundaries between these two classes will be 44.5, and the one before this will be 39.5. And we're jumping by 5 each time. So we're going to fill that information in. I'm going to change my sizes to say 18, and let's see if that will work. 39.5, and then 44.5, and then 49.5, and then 54.5, then 59.5, then 64.5. I'm just adding 5 each time. And then finally 69.5 is the last boundary I'll need to put in. And I can just put them in right there. And as you can see, those are the boundaries between one class and the next. Now, the next question, the next part is the class midpoints. And as you can see, the halfway mark between 40 and 44 is 42. All right, 40 plus 44 is 84, divided by 2 is 42. So now we still have that information to put in. That's relatively easy. 42 plus 5 is 47, plus 5 is 52, plus 5 is 57, plus 5 is 62, plus 5, 67, plus 5, 72. And those are my class midpoints, or my class marks. Those will be the values to represent the represent all the values in that particular class. We do not know what the actual ages are of the 3 people from 40 to 44. So since we don't know, it could be all 3 of them are 40, or all 3 of them are 44, or one is 40, one is 41, one is 43. It doesn't matter. If we need to represent all the values in this class by one number, it would be this guy, the class mark or class midpoint. It's a number that we would use to represent all the values in the class. And so these are my class midpoints. Okay, good. Now, that answers that question. The next question is to draw a frequency histogram and also construct a frequency polygon to represent the data. So we're going to do both of those right here. Now, the next 2 parts are about constructing a cumulative frequency distribution and a cumulative frequency table. So what I'm going to do is I'm going to just create a a duplicate of this page so I can use this data that I just created to help me with the next part. And then we'll come back to that afterwards. But in the meantime, let's look at our frequency, our histogram and our histogram and our frequency polygon. Now, I'm going to use my boundaries. I'm going to create a little a set of axes here. I'm going to try to make it a little bit smaller. And unfortunately, because of the space, my diagram will not be drawn to scale, although I will try to draw it to scale. So what I'm going to do is I am going to put in my my markers for using the class boundaries. So I need 1, 2, 3, 4, 5, 6, 7 boundaries. So let me start by creating some boundaries here. Actually, I'm going to need a boundary at the end of this one, so I need 8 boundaries. So 1 boundary here, and I'm just going to copy that. And let's see if we can work with that. 1, 2, these are approximate widths. 3, 4, 5, 6, 7, 8. And as you can see, my boundaries were a little bit off, but we can fix them all a little bit here just to make the information a little bit more uniform. And if that causes a little problem, then I'll just adjust that afterwards. All right, so hopefully that would be sufficient. It's not, as I said, drawn to scale, but it gives us a little bit of information here. So my first boundary is the 39.5, which is right here. Then my next boundary is 44.5. Then 49.5. Then 54.5. Then 59.5. And then 64.5, then 69.5, and then the final boundary would be 74.5. That would be the boundary. Now I'm leaving another one blank here and one blank here for the class that comes before and afterwards when I do my frequency polygon. Now, what I need is to go up as high as 16. So I'm just gonna do a little, again, rough sketch here. And I'm gonna just imagine that our numbers there are such that we can, we have some nice little numbers here. So all right. I'm having a little technical difficulty here, pardon me. All right, so I apologize for taking all of this time just trying to make everything perfect, but I want to make sure it looks as accurate as possible. And what I've done is I've created the heights of this histogram, and each of these bars is 5 units apart. So that's 5, that's 10, that's 15, and that's 20. And this is the frequency. And this is the age in years. And of course, the column is ages of chief executive officers, ages of CEOs. And I'm going to leave the rest blank because of time and space. Now we're ready to draw our histograms. So the first one has a height of 3. So I'm going to draw a bar graph that is as wide as the one we're looking at here, and its height is 3 units. Okay? So let's see if we can do that. So it's about that high. And then the next one is one as a height of 11. So I'm going to start with this one and go up to 11. And then the next one is a height of 13. So I'm going to start at this one, go up to 13. Again, my diagram is actually just approximate, but you're getting the idea here. The next one is 16, so I'm going to start here and go up to 16. It's just above 15. And if I were to line this up correctly, I would just say, well, that's 16. And then the next one will be 10 from 59 to, from 60 to 62. 60 to 64, that would be 10. And again, I apologize for the annoyance of what I'm doing here, but I'm trying to be as precise as possible in this graph. It's not always the best, but I'm doing what I can. All right, so, and finally, oh, the next two are 6 and let's see what that one looks like. So we have, that's a height of 6, and then we have a height of 1. And I need to just do a little adjustment to this. And there we go. Okay, so That's what our histogram looks like. Went through a little bit of tedium to get it created, but you get the idea of what we're doing here. This is the frequency histogram. Now the question is, how do I get the frequency polygon? And let me just move this title up to the top here. And then I'm going to draw the frequency polygon underneath. All right, so let me just retype this and let's save myself the trouble. Sometimes it's a challenge of trying to get everything perfect. Ages of CEOs. All right, now that is my frequency, my histogram. Now let's do our frequency polygon from this. And what I'm going to do here is I'm actually going to copy this frequency histogram, and I'm going to create a frequency polygon from it. And this is going to take a little bit of technicality, but don't worry about it. So let me just take care of that right now. All right. So that's my polygon, that's my histogram. And then I am gonna, underneath that, I'm gonna create a polygon with these details. So that's my histogram right there. And this is my polygon. Now, how am I going to create a polygon? Very simple. I am going to mark the midpoints of each class. And I'm going to use a different color here. I'm going to use a red. And let me just start with the red just for the sake of the video. So I put the midpoint in each one. I'm just estimating here, but it's the midpoint of each class. And then I put the midpoint of the class before and the class afterwards. And then I'm going to draw a frequency polygon on those. So I'm going to use a red line here. I'm just going to connect starting from the x-axis. And then finally, I'm going to, and one of my lines is slightly out of alignment, but it's not a problem. You have the idea of what I'm trying to do here. And then what I'm going to do is I'm going to just remove my bars. Of course, when you're doing this by hand, you're going to have to do it a little differently, but because I have the benefit of technology, then I can do that. And then the final thing is to just realign my midpoints. My midpoints are no longer are not the boundaries. The midpoints are the class marks. So I'm going to simply shift all of my class marks over by 1 unit, and then that will be my those will be my class my values here. So then I can start saying, okay, this first guy here is 42, then 47, then 52, then 57, then 62, then 67, then 72, and of course then 77 would be 0, and 37 would be the one down here. And this is the polygon. And this, of course, is the histogram. And that's what we have. This is the answer to the question so far. Part A, class width is 5. Class boundaries indicated in the chart. The histogram on the top right here, and the frequency polygon down here. All right, and now we're going to move over to the other side, and we're going to look at the cumulative frequency table and so on. So I'm going to go over to this side here, and what I've done is I've taken the liberty again of creating a table for me to work with, and I'm going to take that table and move it up to the top here, because I'm going to try to create a histogram, cumulative frequency graph underneath, if there's space to do it. Now, this is the last part of my example, but let's see what we can do here. First, I need to fill my class. It's a cumulative frequency graph. So what I'm going to do is I'm going to fill in the information here. I want values that are less than either the class boundary for the next between the classes or the lower limit of the next class. So I'm going to say less than 45. And then I want values that are less than 50. Then I want values that are less than 55. Then I want values that are less than 60. Then I want values that are less than 65. And let me move those into place right now. 45, 50, 55, 60, 65. Then I want values that are less than 70 and less than 75. Okay, now let's take a look at what our answers will be here. Now, the first column, the first row, will always be the first row of the cumulative frequency. The items in the first class are all less than the lowest limit in the second class. So that would be what I put here. So my first information here would be 3. Then what's less than 50? Less than 50 are the items in the first and second class. So I now add 3 plus 11, that gives me 14. What's less than 55? That's the items in all 3 of the first 3 classes, which is the first 14 plus this additional 13, which would be 27. And then what's less than 60? That's all the items in the first 4 classes, which are the first 27 plus this additional 16, which would be 43. And then what's less than 65 is those in the first 5 classes, which is the first 43 plus another 10, 53. What's less than 70? All of these classes, which is the first 53 plus this additional 6, which will be 59. And what's less than 75? All of them are less than 75, which is all 60 values. And that is your frequency, cumulative frequency distribution. That's it. It is that easy. That's the cumulative frequency distribution. Now let's talk about the graph of the cumulative frequency distribution. That's called an ogive. An ogive. So I'm going to do my axes, which is x-axis and y-axis. Now my graph is going to be a little stunted because of the space that I'm working with, but I'm hoping that you all can follow what I'm going to do here. So I'm going to go up by 5s each time. All right, so let's see what we have. We have 5, 10, 15, 20, 25, 30. I still do not have enough of space, so we're going to have to see if we can squeeze some things down a bit, but you're getting the idea of where I'm going with this. And I'm going to have to make some slight adjustments just for the sake of organization, for the sake of the question and the answers that I'm giving. And again, I apologize for the time taken for the technical issues here, but you of course can always skip through some parts of the video to get to the place where the answers are, and you can always check your answers with what I have done to see what works. All right, so this should work now. And now we're gonna start putting down our information. So I'm gonna use my class boundaries as my markers here. I'm gonna use my class boundaries as my markers. So I'm gonna start off with 39.5. And I have 1, 2, 3, 4, 5, 6, 7, 8 markers. All right, I'm almost there. All right, so there we have it. Now we are going to add on our numbers 30. Oh, just a minute here. The computer is a little frozen. 30, 35, 40, 45, 50, 55, and 60. That's my cumulative frequency. So this is my cum frequency. And these are my ages. And I'm using the boundaries. So we're talking about 39.5, 44.5, 49.5, 54.5, 59.5, 64.5, 69.5, and 74.5. And then at 39.5, nobody's there. Okay, nobody's at 39.5. At 44.5, we have 3, so I'm going to put it at right about there. At 49.5, we have 14, so I'm going to put it right about here. At 54.5, we're looking at 27, so we're going to put it right about here, slightly above. And then we are at 43 at 59.5. So we're looking at about right here. And now I'm kind of estimating. And then we're looking at 53 at 64.5. So we're looking at someone like right about here. And then at 69.5, we're talking about 59, which is about right here. And then 74.5 is 60, which is about right there. And then if we draw the ogive using line segments, it would look something like this. Okay. And there we have it. Oh, that's what the ogive looks like. It almost looks like a smooth curve, and usually we try to convert it to a huge curve. And this is a cumulative frequency graph, or also known as the ogive for the data. So cumulative frequency graph, also known as the ogive for the information. And the cumulative frequencies are on the left side and the ages are on the y-axis. And this is the cumulative frequency graph for this information. Now, this has been a somewhat of an extended study, but it's because I've been trying to go slowly enough for you to understand what's going on. I recommend that you review this information and try some questions as well. In fact, here's another question here. This is taken from a book called Elementary Statistics by Neil Weiss, the 8th edition. And you can try this one by constructing the frequency distribution following the details and doing all the information, the questions that are requested here. And what I will do is I will move the instructions over to the left side here so that you can see them right next to the question on one page. And then you can check with your instructor or with other students as to whether you are on the right track. And just a quick review here. Here is the information from the previous questions for the ogive and the cumulative frequency distribution. And this is the new question that I'd like you to try on your own. Additionally, if you go to the introductory statistics book by that you can find at the OpenStax website, I would recommend that you go there. This is the textbook right here. Introductory statistics, that's the OpenStax symbol. You can find that information on the OpenStax website, or you can download the OpenStax app, which you can find on in your app store. And this is what the symbol is for the app. You can use your Apple App Store or the Google Play Store and download the app. And then you can find questions in relation to what we're doing here in the chapter 1 and chapter 2. Chapter 2 in particular deals with histograms, section 2.2, histograms and polygons. And if you go down to the glossary and then go down below the glossary, you have some chapter review questions. And that's where you'll have some nice questions that you can check out. And the answers for some of those questions are in the back of the textbook. All right, so that brings us to the end of our lesson for today. And feel free to check out Khan Academy for some additional support and practice. We have some good videos there for you to watch. That's all for now. Keep practicing, studying, and learning. All the best.